Graphs. Domain and range. A graph is any function represented by f of x, where the horizontal axis represents the variable x and the vertical axis represents the value of the function. Choose a value for x. Calculate f of x. Draw the corresponding point. When repeated for different values of x, the result is a curve or a line and is termed a graph. Functions are represented as graphs to estimate the function values and find the domain, range and intercepts. Even and odd functions are identified by exploring the symmetry in a graph. The function values that is estimated from a graph can be confirmed algebraically. For example, the graph below can be used to find the total increase in population of a country X in the year 2007. If the function is not bounded by a circle or a dot, then the function extends beyond the edges of the graph. The unbounded function is represented as upward or downward facing arrows in a graph. The domain and the range of a graph. The domain of a function refers to all possible x values. The range of a function refers to all possible y values. For f of x equals absolute value of x, the value of x is unbounded with all negative and positive values. Hence the domain is represented with open braces. The value of x is also limitless. Hence, the domain value is algebraically represented as the above. For f of x equals absolute value of x, the range has an upper limit at 0 and a lower limit at -infinity. Hence, the upper limit is represented by a closed brace and the lower limit is open. An intercept in a graph is the point where a graph intersects or meets the axis. The y-intercept occurs when x equals 0 and x-intercept occurs when y equals 0. A graph can have 0, 1, or more x-intercepts, but at the most only one y-intercept. To find the y-intercept algebraically, find f of 0. The x-intercepts of the graph are also called the zeros of the function. To find the zeros of a function f, set the function equal to 0. The relations in a graph can have two types of symmetry. 1. Line symmetry. The graph can be folded along a line so that the two halves match exactly. 2. Point symmetry. A graph can be rotated 180 degrees and appear unchanged. Test for symmetry. In a graph, check for three types: x-axis, y-axis, and the origin. For y-axis, replace x with -x. For x-axis, replace y with -y. For the origin, replace both x and y with their negatives. If the equation remains the same, the graph is symmetrical.